You know that feeling, right? You have this amazing idea in the shower, and poof, it's gone just a few minutes later. It's so frustrating. Well, what if I told you that's the reality for most modern AI? They're these incredibly smart minds, but they have the memory of a goldfish. And that brings up a huge question, a really big one. Can you really be intelligent if you can't learn from your own past? Can an AI have one of those genuine eureka moments? That's what we're going to explore today. And look, this isn't just some abstract philosophical question. It's the real deal. It's probably the biggest single thing holding AI back from helping us with our grandest challenges. Stuff like discovering new medicines or tackling climate change. Those aren't problems you solve in a single sitting. Nope. They take weeks, months, sometimes years of just grinding away, building one insight on top of another. For an AI with a memory that resets every few hours, that's been pretty much impossible. But, and this is a big but, that might be changing.
Okay, so to really get what's so special about this breakthrough, we first need to wrap our heads around the problem. And it all comes down to the AI's brilliant but, tragically short memory. Let's call it the goldfish memory problem. So today's large language models, they're incredible sprinters, for sure. You ask one to whip up a poem or fix a quick bit of code, and boom, it's done. But ask it to run a marathon, like managing a complex research project that takes days or weeks. It just falls apart. It completely loses track. It forgets what it already tried, it forgets why something didn't work, and it even forgets the main goal. It's kind of like a genius scientist who shows up to the lab every single morning with total amnesia, having to relearn everything from day one. This ability to stick with these huge long-term projects, well, there's a fancy name for it, ultra-long-horizon autonomy. But really, it's just about having the stamina to work on one massive thing for days or even weeks without losing focus. It's about not getting bogged down in the tiny details while still remembering the big picture. Just like a human scientist does. It's kind of the holy grail if we want AI to be a true partner in discovery. The technical reason for this meltdown is something called context saturation, and here's the best way to think about it. Imagine the AI's short-term memory, its context window, is a small desk. As it starts working, it just piles everything on there. Notes, code snippets, error messages, log files, you name it. And pretty soon that desk is buried under a mountain of paper. The AI literally can't find what's important anymore. It's just drowning in the details of its own work, and the big picture is totally lost. So, what do you do about that? You might think, well, just give it a bigger desk. But it's not that simple. The problem isn't just the sheer amount of information, it's how that information is organized. The real solution? It's to stop thinking of AI memory as just one big box and start thinking of it more like a brain. And the inspiration for this actually came from something you're using right now, your computer's processor. See, your computer doesn't have just one giant memory bank. It's way smarter than that. It has layers of memory. We call them caches. They're super fast, small memory for what it's doing right this second, and then bigger, slower memory for long-term stuff. So the researchers thought, what if we could build an AI, a brain that works the same way, with different levels for different kinds of memory? And well, that's exactly what they did. They call it hierarchical cognitive caching, or HCC for short. And it is a total game changer. It's a new kind of architecture that gives an AI different types of memory for different types of thinking. It's a system that lets the AI take this chaotic flood of raw experience and actually turn it into lasting, useful wisdom. So what does this new AI brain actually look like? Well, it's got 3 distinct layers, and each one has a super specific job, all part of this journey from just raw experience all the way to real wisdom. Let's break it down. Okay, so level 1, or the L1 cache. This is the evolving experience layer. The best way to picture it is as the AI's messy work desk. This is its working memory, right? It's cluttered with all the immediate stuff, the code it just wrote, that error message that just flashed up, the results from the last 5 minutes. It's chaotic, it's super high detail, and it's absolutely essential for what it's doing in the moment. But it's not meant to be kept forever. Next up, we have the L2 cache. This is where refined knowledge lives. So, after a work session, the AI doesn't just trash everything on its messy desk. Instead, it takes a moment to reflect. It sorts through the mess and pulls out the really important stuff. It creates these neat little summaries like, hey, using that method boosted performance by 10%, or okay, that feature was a total dead end. This refined knowledge then gets neatly filed away in the L2 cache, which is like a perfectly organized filing cabinet. And that brings us to the top level, the L3 cache. This is the prior wisdom. Think of this as the AI's grand library. This is its deep, long-term memory. So when an entire project is done, it reflects one last time, but it asks a much bigger question. What did I learn here that I could use on any project in the future? These are the universal truths, the timeless lessons, maybe a super clever way to process data or a really solid model design. These get written into books and stored in its library. This is the wisdom it carries with it forever, to any new problem it faces.
So you see the process here, right? It's beautiful. It's this flow. Raw experiences from that messy L1 desk get processed. Then, the most important insights get promoted and summarized into the neat L2 filing cabinet. And finally, the truly universal strategies get distilled down and archived in the L3 library. Information doesn't just get stored, it gets smarter. It evolves from fleeting experience into permanent wisdom. That's what they call cognitive accumulation. Okay, this all sounds fantastic in theory, right? A messy desk, a filing cabinet, a library. But does giving an AI a structured brain actually make it better? To find out, the researchers put their new agent, named ML Master 2.0, through the ultimate trial by fire. This test is called MLE-Bench, and it is no joke. It's a grueling collection of 75 real-world, super difficult machine learning competitions, the kind you'd find on platforms like Kaggle. Every AI agent is basically just thrown into the deep end with a brand new problem and a 24-hour clock to solve it. This isn't just a quick test. It's an absolute ultra-marathon that demands real strategy, a great memory, and, well, a will to win. So, how did our new AI with a brain actually do? Get this, ML Master 2.0 won a medal, that means a bronze, silver, or gold performance, in over 56% of the competitions. That is absolutely stunning. I mean, in this field, just getting a valid answer is considered a huge win. This is next level. And let's put that number into perspective for a second. Its predecessor, the original ML Master, it only got medals about 29% of the time. And the previous best system out there, an agent called Liru, it maxed out at just under 51%. So ML Master 2.0 didn't just nudge the bar forward. It took a massive leap. It's a testament to just how powerful this new brain-like architecture really is.
But here's what might be the most important part. You see, a lot of other AIs, they do okay on the easy stuff, but their performance just tanks when the problems get really hard. Not ML Master 2.0. It stays incredibly strong, no matter the difficulty. Because it can manage its memory and build on its wisdom, it doesn't get overwhelmed. In fact, the harder the problem, the more its unique brain seems to shine.
And maybe the most mind-blowing stat of all? This isn't just about an AI beating other AIs. In over 63% of these tasks, ML Master 2.0 performed better than the median human participant. We're talking about skilled professional data scientists and ML engineers. This thing isn't a toy project, it's a world-class competitor. So what does all of this really mean? I mean, this is so much bigger than just winning some coding competitions. What we're looking at here is a fundamental shift. We're seeing the first real steps of an AI that can think, reflect, and strategize for the long term. This is the dawn of something new. And the researchers who built it, they see it that way too. In their own words, they see this as a scalable blueprint for autonomous agents capable of orchestrating the full life cycle of scientific discovery. I mean, just let that sink in. They're not talking about an AI that just runs a task we give it. They're talking about an AI that can handle the whole messy, creative, and rigorous process of science from start to finish. What we're seeing is AI's evolution. It's changing from being just a brilliant but forgetful tool, kind of like a superpowered calculator, into a genuine partner in research. Because it's learned how to remember, how to reflect, and how to build up wisdom, AI can finally join us in that messy, often frustrating, but totally beautiful process of discovery. It's becoming a collaborator that doesn't just spit out answers, but helps us ask bigger and bolder questions.
So the question really isn't if an AI can have that one single eureka moment anymore. The real question is, what happens when it can have thousands of them, day after day, building on each one? What problems, the ones we used to think were impossible, might we finally solve with a tireless partner that literally never stops learning?